Oh, hi. Good day, everybody. How are y'all doing? Okay. Um. So, let's see. Do I have any announcements to make other than remember that next week is our exam week. We will spend Monday reviewing. There's the unit review. You can find that under in the course content. Let's see. Hold on. Nope. Let me do something real quick. Um, okay. I just sent uh, an email announcement regarding Unit 1 review. Um, I'll show you where it is real quick, that way you can see. Here we are in Blackboard. go to course content, folder down at the bottom called Unit Reviews. Then there's the Unit 1 review. And all it is a well, let's see. Where's the rest of the pages? Why is it not loading up the rest of the pages? Pages are all there. It's just my iPad is acting funny. There we go. A review. So what I would do is we're going to have a quiz on Friday. That quiz will be over assignment 5 and 6. We will continue to address questions today, but since assignment 7 is going to be reserved for Fridays, or we can answer assignment 7 questions today, but I'll just go do a quiz over 5 and 6 on Friday. On Monday, we can review, we can answer any questions that you want from the homework or from the review, and then on Wednesday and Friday of next week, we have our exams, part 1 and part 2 of exam 1. So that's my announcements. I want to basically quit talking and open up the floor to you regarding any questions that you may have.
Sir,
Yes.
are you ready for questions?
Yes, I am.
Can you go over number 14 on assignment 6?
Sure. All right. Assignment 6. Number 14. So what do you do first in solving this problem?
You get rid of the exponent?
Before that, you need to get the 12 to the other side. So what you want to do, sorry, and I forgot the variable. Um, what you want to do, just like if you had 6x minus 12 equaled 0, just like in this problem right here, the first thing that you would do is you would get rid of the 12 by adding 12 on both sides. The same thing here. We're going to add or subtract constants over to the other side to start isolating the 6x to the 5 halves. Equals 12. Now, just like over here, the next thing that you would do, what would be the next thing that you do over here where my pencil is?
Divide by 6.
Divide by 6. Same process over here. You're going to divide by 6. Now is when we start taking care of that exponent. So, I talked about this in one of my classes yesterday. What we're trying to do is we are trying to undo what's being done to x. So, right here, the first thing that's being done to x is it's being raised to the 5 halves. Then it's being multiplied by 6. Then it's being subtracted by 12. So you're undoing that process. So if the first thing that was being done to x was being raised to the 5 halves, that's going to be the last thing that we undo. So hear me. Listen to my words. 5 raised to the x to the 5 halves, then multiplied by 6, then subtracted by 12. To undo that, you're going to undo the last thing first. So the last thing that happened was subtract by 12, so we add by 12. Then the next thing, the thing that happened before subtract by 12 was multiply by 6. We undo multiply by 6 by dividing by 6. Now we're ready to undo the very first thing that's happening to x. The very first thing that's happening to x is it's being raised to the 5 halves. We want to undo that. To undo that, we're going to raise both sides to the 2/5. So, a couple of things that we need to know. Things that we need to know. X to the a over b. How do we express x to the a over b? The a is the power of x. B is the index of the radical. Anytime you have a rational exponent, the denominator is the index of the radical. Now the cool thing about this is the a doesn't have to stay inside the radical. You could take a to the outside, so now you're doing the b root of x first and then taking it to the power of a. So when I look at this problem, 2 to the 2/5, you might first write it like this: 2 to the second power, 5th rooted. Now, 2 to the second power, that's pretty easy to do. 2 to the second power is 4, 5th rooted, and that's the answer that we want. x is equal to the fifth root of 4. Now, I don't want the decimal answer, but you should know how to find out the decimal answer for this value. Do y'all know how to take the fifth root of something using your calculator? Yes or no? No? Alright. Your calculator does x squared, right? You know how to do x squared on your calculator, or let's better yet, you know how to do 4 squared on your calculator? Okay, good. Most calculators have the exponent button of 2, 16. Do you know how to do 4 to the third on your calculator? So you're probably doing something like that, right? With your calculator? Now, to do the fifth root of 4, that is the same thing as 4 to the 1/5 power. So just like taking 4 to the third, you take 4 and you raise it to you do your little housetop button and you do 3. You're going to do the little housetop button, but you're going to make sure to put the 1/5 in fractions, or in parentheses. So do that with your calculator. What do you get? You should get 1 point something. I don't know where my calculator went to. Where is I have lost my calculator. I don't know where my calculator is. What do you get? 1 point what? You tell me.
1.32.
1.32?
Yes.
So I can test this. If I take 1.32 and then raise it to the 5th power, I should get pretty darn close to 4. You get pretty darn close to 4?
Yes.
Yeah. The 1.32, that's probably an approximate, right? There are probably more decimal places. That's why I use the approximate symbol. But that's how you take the 5th root of something. You raise it to the 1/5. Make sure that these are in parentheses in your calculator. Because if you don't put them in parentheses, you're going to do 4 to the 1, which would be 4, then divided by 5, which is not going to be the 1.32. Alright, so this is as simple as we can make this answer. I don't want the decimal number. The reason I don't want the decimal number is because this is only an approximate. I want the exact answer, so one of the things that you're going to learn in this class is that this is approximate. This is exact. I want exact answers. So because the numeric form of this is only approximated, it's called irrational because the decimal numbers just keep going on and on forever and ever. I want the exact answer. Alright, does that answer your question on how to tackle that problem?
Can you go over number 15?
Alright, if this was on the exam, well, first of all, when you read this question, the directions say solve the quadratic type. So, it's already telling you that this is a quadratic type equation. So, if you watch the lecture videos, you know that to solve the quadratic type equation, you use a substitution. But I want to backtrack just a moment. Let's pretend I gave you this problem on the exam. I'm not going to tell you that's quadratic type. I'm just going to say solve. That's all I'm going to tell you to do. I'm not going to tell you what kind of equation it is. I'm not going to tell you how to solve it. All I'm going to do is say solve. So what you have to do is you have to start looking at this. You got to start asking yourself, what kind of equation is this? You got to be able to look at this and say, what kind of equation am I dealing with? And then once you know what kind of equation is, then you can start saying things like, oh, this is how I solve it. So, this is where you start putting on your thinking hat, your detective hat, and you start analyzing the question. So, here's the things that I notice. There's three terms. 1, 2, 3 terms. Quadratic equations have 3 terms. This has 3 terms. That's the first thing I noticed. Second thing I noticed is that there's a constant. Most quadratic equations also have a constant. Now, the third thing that I notice is this. If I take x squared here and I square it, I get x to the 4th. So, these 3 things that I notice lead me to the conclusion that this is quadratic type. Quadratic equations have 1, 2, 3 terms. There's a constant, and if you take the middle term, the middle variable, x, and you square it, you get x squared. Those 3 things, 3 terms, a constant, this relationship between taking the middle variable and squaring it to get the first variable, are what are telling me that this is quadratic type. So, once you know what kind of equation is this, it's quadratic in type, then you know that to solve, you're going to use a substitution approach. To solve this, you're going to use a substitution. So here's what we're going to do. We're going to let u be equal to x squared. Now you might ask me, how do you know what to let u equal? You always let u be equal to, in most cases it's going to be the middle variable. But what you want is you want u to be equal to this term so that u squared becomes, let me write it out like this. U squared is then x squared squared, which is x to the 4th. You choose the u such that when you square u, you get the other term. If I let u be equal to x 4th, then u squared would be x to the 8th. Well, that's not what this is. By letting u be equal to x squared, u squared becomes the x to the fourth. So we let u be equal to x squared, then u squared becomes x to the fourth. Now we get to say things like this. Now we have, instead of x to the fourth, we have u squared minus 5u plus 4 is equal to 0. Are you with me so far? Solve. How do we solve this quadratic equation? Well, I would probably factor it. Sorry. Which then means that u minus 1 is equal to 0, u minus 4 is equal to 0. Which then means that u is equal to 1, and u is equal to 4. That's great, but I don't want to know what u is, I want to know what x is. So here's where I apply this substitution here. So we go on to say the following. X squared is equal to 1. X squared is equal to 4. Now we solve these equations. Excuse me, sorry. Yeah, how do we solve this? Square root both sides? Come on, iPad, behave. Square root both sides, and what do we always include when we square root? Plus or minus. X is equal to plus or minus 1. X is equal to plus or minus 4, not 4, but 2. And that's how we solve this problem. So, what's required of you is to determine what kind of equation that you're dealing with. So, you look at the equation, you start analyzing it. I make note of the fact that there's 3 terms. There's a constant. Take the middle variable, square it, you get the first variable. That leads me to the conclusion that it's quadratic type, which tells me that to solve it, I'm going to use the u substitution technique. So we let u be equal to the middle variable, then we square it, you get the first variable and its exponent. So we create this quadratic equation that we solve. Once you know what u is, you go back and resubstitute x squared for u and solve this. So, I want to take the opportunity here to give you, I want to give you the opportunity to solve things like problems 16 and 17 for yourselves, and I want to show you that I can make this. So let me just go to the next page real quickly. X squared, or excuse me, x to the fourth minus the 5x squared plus 4 equal to 0. I could do a rewriting process And I could write it like this: x minus 5x to the 1/2 plus 4 equals 0. And what I've done is I've created another quadratic type equation. So notice that there's 1, 2, 3 terms. There's still a constant, and check this out. If you take x to the, I'm sorry, that should not be 1/4. That should be 1/2. My apologies. If you take x to the 1/2 and you square it, that becomes x to the 1/2 times 2/1, which is x to the 1, which is x. That's this term right here. So then what you would do to solve this problem is you would let u be equal to x to the 1/2, then u squared is equal to x, and then you create another quadratic equation, and not u, sorry. Then you create another quadratic equation, and we know the result here because we did it back over on the previous page. When I had u squared minus 5u plus 4, I ended up with u equal to 1 and u equal to 4. Alright, so we don't have to do the work here. We already know what happens. U is equal to 1, u is equal to 4, but then you apply your substitution, so all I've done is I've used the same setup over here. I've used the same setup in terms of the coefficients here, but I just created a different type of quadratic inform equation. It still holds that if you take the middle term and you square it, you get the middle variable, and you square it, you get the first variable. Now all you got to do is just solve this guy. How do we solve this? Square both sides. There we go. So I did that one so maybe that you can tackle problem 17 all on your own. 17 is almost set up the exact same way, except you have different coefficients. Alright. Your turn. What else can we look at?
Can you go over 13?
Sure. Yes. Sorry, I was taking a drink of water. 13. Did you attempt this problem? Did you try it?
Yes.
What'd you do first? What's the first thing that you did? That's a 1/3, sorry, by the way. That's a 1/3. What'd you do first?
They multiplied its reciprocal.
Good. So I'm going to correct your language there. You didn't multiply by the reciprocal, but you raised both sides to the reciprocal power. What'd you get after that?
X plus 3 by itself. Equals 8.
Okay, now what?
Subtract 3.
And what do you get?
5.
There you go. What was that? Alright, so somebody asked about this question. It sounds to me like you did it correctly. Did something go wrong?
We just put it into the square root.
She square rooted by 2 instead of the 1. Instead of the power to the 1, she actually put it in the square root as if it was a power of 2.
Oh, okay. Yeah, it's a 1/3, not a 1/2. That makes a difference.
Okay.
Excuse me.
Can you show me 23?
23. Alright, so first things first. Never, ever distribute into absolute value bars. Never, ever distribute into absolute value bars. These are a type of grouping symbol, but they have a special, I would say, rule that says never distribute into them, never factor a GCF out. Think about, first of all, isolating the absolute value. So what are we going to do in this problem first? What's the first thing we're going to do?
Divide by 3.
And when you divide by 3, you get 7. Alright, so I'm just going to rehearse the concept here. Thought, idea. If the absolute value of x is equal to 7, then x could be equal to 7, or x could be equal to -7. So, let's just think about it. Absolute value of 7 is 7, okay? But if you put -7 inside the absolute value bars, absolute value bar of -7 is still going to make 7. So there's two possible values of x that can plug in here, so that result is 7. So the same thing is going to apply here. The inside of this 2x minus 1 could be equal to +7, or it could be equal to -7. So that means the following. So there's the idea. The conclusion is this. For absolute value of A equal to B, A is equal to plus or minus B. So for our statement over here, the conclusion is that 2x minus 1 is equal to plus or minus 7. This is two equations. The first equation is the 2x minus 1 equals -7. The second equation is equals +7. Alright, does that make sense so far? Yes? Okay. Then I would just go through and solve. Alright, add 1 to both sides, so that's 2x equals -6, which then means x is equal to -3. Add 1 to both sides, 8, which then means that x is equal to 4. And there's my two solutions. So this is one of the big ideas that I talked about in the notes. How to deal with absolute value equations.
Can you go over number 10?
Go over what?
Number 10.
10. Alright, this is a lengthy one, so this is probably the last thing I get to do today. So the idea that we're employing here is that if you have the square root of a and you square it, the exponent 2 and the radical cancel out and you're just left with a. So we're going to be squaring to get rid of the radicals. But what we need to do is we need to isolate a radical. We want to get one of the radicals completely by itself. So I'm just going to move this radical to the other side by addition. Get a radical by itself. Your life is going to be easier if you get a radical by itself first. Then we square both sides. Now here's the First of all, everybody gets this first part right. Alright. Radical and exponent 2 cancel out. Inevitably, somebody's going to mess this up. Someone's going to just say, oh, take the 2 to the 1, take the 2 to the radical, and do that. No, 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 no. You have to think about what this means. It means that you have a binomial times a binomial, which means you're going to FOIL. And that's not going to give you the same thing as if you took 2 to the 1 squared and radical squared. You got to FOIL. 1 times 1 is 1. 1 times the radical is the radical. Radical times 1 is the radical. And then you have radical times itself. So a couple of things happen. First of all, we can combine these two terms together. Radical plus itself is 2 times that radical. Radical squared, radical goes away. So, at this point, what we've done is we've gotten rid of the radical around the 2x minus 3, but we still have a radical around the x minus